Welcome back to Unnati Education videos. So in the last video, we have seen what is average velocity. We understood what is average velocity, and also we got an equation for that, and the unit we understood, and also we got the relation that is between average speed and average velocity. Okay, this much you remember, I hope. We'll move to the next topic now, that is uniform velocity. When velocity is said to be uniform, that is given here, if an object covers equal distance in equal intervals of time, then that is in uniform velocity. That object is said to be in uniform velocity. Got the meaning? If an object covers equal distance in equal intervals of time, okay, that is, suppose if the object moves 5 meters in first 5 seconds, then in the next 5 seconds also it should move 5 meters only. Like that, if it continues, we can say it is under uniform velocity. Okay, that is what you call as uniform velocity. That is the meaning of uniform velocity. Okay, next. Now we have to see one type of graph that is called position-time graph. Position-time graph. So usually question appears, what is position-time graph? They will say in the final examination to draw a position-time graph. With that question, it may be asked that what is position-time graph, or it may be asked for defining position-time graph. The definition is given here. This is the graph representing position along y-axis and time along x-axis. See here, position is along y-axis and time along x-axis. Horizontal axis we always take it as x-axis, and y-axis is vertical axis, right? So that is the definition of position-time graph. You have to remember that. So first type of graph you can see here, that is for stationary object. If the object is stationary, that means if it is at rest, means what? Its position will not change, right? Position will not change. Even if you see after some time, position will not change. Time will change, right? Obviously time will move, but position will not change for the object. That is why the graph will be like this, a straight line parallel to the horizontal axis, time axis, right? Position will not change. Position is same. And time will change. That is for stationary object. This is a position time graph given for stationary object, means object at rest. Okay. Then this you can see second graph here, that is for uniform positive velocity. Uniform positive velocity. Uniform velocity, if you understood, right? Here, if an object covers equal distance in equal intervals of time, that is uniform velocity. So here the case is uniform positive velocity. Suppose velocity has got direction. Suppose if the object is moving along positive direction, suppose if we take it as positive direction, position will increase, right? Suppose if you consider somewhere here 0, 1, 2, like that. Here it will be -1, -2. It has got direction. That is why, suppose if the object starts from 1 or 0, it is moving in the positive direction. That means position increases. If the increase of position is uniform, that is what you call as uniform positive velocity. Uniform positive velocity. So this is the graph given for uniform positive velocity. position increases uniformly with the time. Okay, just remember this graph. This may be also asked for exam with the definition for positive time, the position time graph. Okay, position time graph's definition will be asked. With that, this graph will be asked. This will be for 2 or 3 marks. Okay, next, for uniform negative velocity. See here, uniform negative velocity, you understood, no? As I mentioned, I explained for uniform positive velocity. Similarly, if the direction is negative direction, if the object is moving in negative direction, as velocity has got direction, it changes its position in negative direction, and that change of position is uniform, means it has got uniform negative velocity. For that kind of motion, this will be the graph. Okay, so just remember, again, the definition is important, this graph is also important. So 3 types of graph, very important for examination. That is, first one, the definition is important, position time graph. With that, for stationary object, for uniform positive velocity, and for uniform negative velocity. Okay, then in the next video you will see about average velocity for from position time graph. Suppose if position time graph for an object is given, how to find average velocity from that graph, this we will understand in the next video. So till then, what and all we have seen in this particular second unit that we are discussing, that is, which unit we are discussing, that is motion in straight line. In this unit we have seen about mechanics, statics, dynamics. Their definitions we have seen. What are the kinetics, motion, rectilinear motion, rest, point object, path length, displacement. Then we have seen so far about an example. With an example we explained displacement and path length. Then their differences, average speed we have seen, average velocity, uniform velocity, position time graph, and different situations. Stationary object, uniform positive velocity, and uniform negative velocity. This much we have seen. All are important for the examination. So once again go through the videos and remember all the points. Okay, so thank you. We'll meet in the next video. Okay.